So, quick takeaways before break. Number one, Carrie found a cool app for Android. Just real quick. Carrie found a really cool app for the Android system, the Android operating system for phones that'll install a TI-83 for free. I don't know. I'm going to have her send me a screenshot and spread it to all you guys. Okay? I'm going to have her send it to me. I'm going to spread it to all you guys. I'm going to see if there's an iPhone version 2. We'll do what we can do. We'll get that out to you. The office hours this afternoon. So in a couple hours, I'll get that out to you as soon as I can research it myself. Secondly, if anybody needs that booklet about intersect, just shoot me an email. What I can do is, as long as one person sends me the email, I can post it on the schedule page so everybody can have it. But just somebody remind me to do it, because you know me and I'll forget.
There we go.
Okay? Alright, good. Alright, so however you decided to solve this last equation, we know that when y is 40, x is 6.6 approximately. Fantastic. And that's what you would have done in Math 60, and then you would be done. You'd be like, okay, next question please. No, it's Math 105. What does that mean? Let me see hands. What does it mean that you found x and x is 6.6 when y is 40? Because Sean's never done with that. He wants to know why. Because he's Sean. Carrie, go!
My guess is that it's supposed to be like 1996.
Good! Sometime during 1996, what happened?
49.4,
Boom! 40 million, Haley, 40 million people became uninsured. There's been a climb in uninsured people from 1992 to 2000 in roughly a linear fashion. It happened sometime in 1996 when it first crossed the 40 million mark. That's what we're talking about here. Very, very good connection of the 6.6. There was a great question came up from Alicia about the 6.6. Should we round that up to 7? Or should we leave it at 6.6? I've got a very, very good answer for that if you don't mind waiting about 30 minutes. There's a statistical answer. Have you guys ever seen how they track hurricanes? When they're trying to predict where a hurricane... Do we have hurricanes on the West Coast?
No.
What are the offshore storms called here? Are they called tsunamis? Okay. Well, if you're ever trying to track a storm like a hurricane or a tsunami that's traveling like over water or over a large flat area, they'll often have data points as to where it was over a certain time period, and then they predict where it's going to go. Have you ever seen graphically when they do the prediction, the paths widen like this the further time they go out? That's called a confidence interval. Which means if you're making a prediction based on data, you have to admit that your model, although the best fit, is not a perfect fit. And if you go past the model, you have to allow for some uncertainty. So the 6.6, technically speaking, would have to have bars on both sides of it, low and high. So I'll get back into a more concrete example of that later on. But that's technically the best answer, Alicia, is to ask for the lower and upper limits on the estimate. I'm not going to require you to do that in here. That's what we do in 243 and 244. That's a big chunk of 243 and 244, is coming up with the high versus low. But that's the best answer to your question is 6.6, that level of precision is a little bit fictitious. To call it 6.6 or 6.57 or 6.57013. It's like, okay, I've got 10 decimal places of accuracy. You're not actually allowed to have them all based on the context. Randall, go ahead.
srule@cocc.edu?
Yes, thank you, sir. Much appreciated. Much appreciated. Thank you. So just realize what that means is sometimes, you see why it's 1996 though, yes? 6 years, 6.6 years past 1990. So 1996.6, which is sometime in 1996. Cool? Excellent, excellent. Let's finally come to the current age. Predict the number of uninsured Americans now. Now. Go ahead and use 2014. Why not? We're about a third of the way through 2014. It's almost May, which is depressing. Did you guys have a nice Earth Day yesterday? Very nice. Because it's going so fast.
Oh, but it's almost summer, so it's good.
Okay, that's a good thing to be happy about. Bend only has 2 seasons, winter and August. So technically, in the grip of winter. It was snowing this morning at my house. And the sun came out, it still kept snowing. How many are solving it manually? Plugging a year into the equation? How many are going straight to the... What would you go straight to? Curious. Thank you, John, straight to the table. Because John knows, okay, he looks up there and he goes, I don't see any numbers in this, right? So in order to use the table, there's 2 situations when you have an equation that has a y and an x in it. You can have the y and solve for the x, or you can have the x and solve for the y. When you have the x and are looking for the y, which tool should you use? When you have an input, x variable input, and all you want is the y, Using the TI, which of the two tools should you use? Well, value is okay, although it won't work very well here. Thank you for that, Ryan. There is a value command. Oh, John, whoever that was. Whoever the hell said that. Thank you for. I hear a male voice. I hear a male voice from that area of the room. That's okay. The problem with using the value command on this is it won't let you without changing the window. So the best thing to use if you're using your TI for this one is actually to use the table. The table asks you for X values and pops out Y values, yes? So as far as the table value goes, let's turn this off. You're in your table. We got to put in 2014, but you'd have to put in a number of years past. Don't put in 2014. That would be 2014 years past 1990. We're all dead and gone, as are our kids and their kids. So we don't do that. We want to go 24 years, yes? 24 years. FYI, just so you know, you might not know this, the TI can actually do mathematics in its little line there. You can actually put in 2014 minus 1990, and it'll come back with 24. I mean, you could actually put mathematics in there if you don't want to actually do mathematics yourself. Ryan, go ahead.
I got a question. Are these numbers being taken from the beginning or the end of the year?
That's a damn good question, which is why I had to think about 2014. Should we use 2013? When does the Census Bureau pull these numbers? I don't have a good answer. You use 2013 if you want to.
Because politically speaking, shouldn't the numbers drop down to 0 by the end of this year?
Oh, good call. Good call. We'll leave politics out of it, brother. Focus on the mathematics. Technically speaking, I guess you're right, though, yes?
Yeah.
But that's okay. Mathematically speaking, everybody see this? So the prediction is, this year, politics aside, we should have 58.3 million uninsured Americans. 58.3 million uninsured Americans. Fair enough? Now, again, Alicia, there should have a plus or minus on it. There should be a low estimate and a high estimate around that. But we'll get back to that, like I said, momentarily. Fair enough, though? You saw how he did that. If you did it manually, what would you have done? Remember what Francis said earlier? If you did it manually, you would just simply
24 into X.
24 into X times 1.05 plus 33.1. You'd essentially extend what Francis did for 1995 and just keep going for 2014. The assumption being what? Of course, the assumption being that each year that passes...
Another 1.05 million.
Thank you, Carrie. Another 1.05 million people become uninsured. That's a big assumption, yes? I want to come back to that right now. Everybody okay with the mathematics, though? Everybody okay with the mathematics before we go anywhere else? Good. So, what I want to do is I want to look at more data than just those 10 years I gave you, or 8 years I gave you data for. This is the graph I pulled that data off of. You can actually find us in that graph. 1992 is right here. There's 4, there's 6, there's 8, and there's 2000. And if you track that up, you can actually see the millions of uninsured people that we had in our data values on the graph there. Number of uninsured. You see that right there in the red? Number of uninsured. Notice how it's not perfect. It's not a perfect line, no? No, it's not. But it is trending upward. Yes, it is trending upward. But watch. If you look at it a different way, if you look at the percent of uninsured people in America over 1978 to 2007, it went from about, what is that, say 12%, I'm guessing? 0, 10, 20, want to call that 12? Is that fair? Mm-hmm. To 16.6. The number of uninsured went from 20, I'm going to call that 23, maybe 24 million, up to 43 million, which essentially means it almost doubled. The number of uninsured almost doubled, if you look at strictly the number of uninsured. Yes? Mm-hmm. How about the percentage of uninsured? How much did it change? It changed, but not as much, yes? Now, can you see how news media outlets will spin this, yes? It depends on what point you want to make. If you want to talk about how bad the uninsured problem in the country is, which one are you going to look at? You're going to look, and they make it red, so it jumps out at you, yes? You're going to make it red. Now, I actually pulled this off of the CDC, and why does it Center for Disease Control? Oh, because it's health insurance. CDC and the National, what was NCHS? Child? Human Services, maybe?
Health Services?
National Health Statistics Report. I forget what that acronym stands for, though. The CDC, it's from the CDC, it's a subgroup of that. Regardless, it's decent data. It's decent data. So you see how both of these say the same thing in different ways, yes? So this one chooses to ignore the population change in the country over that time period. Yes, of course, there are more uninsured people from 1978 to 2007. That's because there are more people in general from 1978 to 2007. What's interesting to me is that this is almost flat. And according to Ryan, it's going to go to 0 at the end of the year. But even if it doesn't go to 0, chances of, look at our estimate. Let's go back to our estimate. What was our estimate in 2014? Remember what our estimate was? 58.3 million? Oh, it's off the charts here. Does it look like it's going to get to 58.3 million if that trend continues? I don't think so. Unless something crazy happens out to 2014. This is as far as I get data from. 2014 is going to be over here somewhere, yes? Unless this ramps up and changes slope, it's not going to hit 58.3 million. Which means that we could have possibly made an error with our model taking it out too far. That's the problem, Alicia. That's what your question was so awesome about was, you can't just take a number off that model and say this is the answer. You have to also give it wiggle room, much like you're tracking that hurricane. Here's the last data point you have, legitimate data point. In 2007, they knew there was 43.3 million people. Any prediction we make past that has to have error built into it, because we're not going to be exactly right if we predicted past that. So when we say 58.3 million, we probably actually have to put a plus or minus 10 million, honestly, on both sides of that in order to account for that plus or minus. Kelly, ask me that question.
What question?
I thought you had one. I'm sorry. I saw a hand, and I assumed it was yours. Remember, I'm the amphibian looking for motion. Maybe you just yawned. That's okay, too. So that's the problem with, I want to talk about real quick, interpolation, extrapolation. This is how you can get into a lot of trouble. Extrapolation. What does extrapolation mean? We just did it. Go ahead, go ahead.
Isn't it using data that's outside the 20?
Very nice. Perfectly said. Tell me your name again. Shelby, thank you. Shelby said, you extrapolate when you try to pull data values outside of your data set. Actually, not when you try, when you do. When you pull data points outside of your data set. So our data set only lived from 1992 to 2000. Here's our data set, friends. Right there. Right there. When we go outside that data set with only the data from our data set and we try to predict with that, whether backwards or forwards, that's called an extrapolation. And there are ways to control the error in the extrapolation, which we'll get back to when we start measuring our forearms. But the idea is there is always going to be error in an extrapolation. And you have to be able to mitigate for that. Is that fair? So just be careful when you extrapolate. When you go outside your data set, you have to be aware that this is why our economy collapsed 5 years ago. People kept saying, oh, look at the pattern, look at the pattern. I bought a house, 2 years later it doubled in value, 2 years later it doubled in value, 2 years later it doubled in value. The next 2 years it's going to double in value again. You just extrapolated. You just extrapolated, didn't you? And unfortunately, it didn't double in value. It went down by about a tenth, if not more, in value. So that's the problem. You assume a pattern is going to continue. That's why I made a big deal when I said, assuming, and then Carrie said 1.05 more each year. Assuming 1.05 more each year, it's going to be at 58.3 million. But that's a big if, isn't it? That's a big if. Be careful. I know you can do the math. It's being able to see if the result you gave me actually makes sense. Please, Carrie.
So part of this graph, in the percentage of uninsured, they did ignore some critical data.
What do they ignore?
I'm asking the number of uninsured because it seems so different to make it look worse than it is.
That's the thing. When you have an incomplete data set, you have to make, our data looks different enough. In other words, it caught some of these spikes. Like 94, it caught that spike. 90, looks like we caught a spike in 96. So in other words, our data might be artificially high. If we used all this data, we'd get a much better look at it. But at the time I originally made the problem and that booklet, I only had the 5 data points. I had to go back in and that's when I found this. And I said, how interesting. The 5 data points that I got from USA Today, FYI, those 5 data points we started with were pulled out of USA Today back in 2002. Then I went back and found this. I'm like, why would USA Today have used 5 data points with such an extreme value? And then I wondered if they were trying to make a point about the number of uninsured in the country. That's when I start wondering. That's when I thought it would be good for you guys to see this.
Instead of the percentage of...
Exactly, because the percentage doesn't make it seem like anything's going on, right?
Right.
If it goes from Well, this actually makes it looks like it went up and then went back down.
Right.
You can't argue that more people are uninsured if a lower percentage are uninsured. Unless you can do division in your head, which I know I can. So, does that make sense, Gary? I love your point. It's just that depending on what the news is trying to say, they can show it to you either of these two ways. We need insurance reform. We don't. You see? They're both saying the same thing, but they're saying it in two different ways. That's why you've heard the phrase, there are lies, there are damn lies, and then there are statistics. You've heard that, maybe you haven't. Well, you heard it now because I just told it to you. There are lies, there are damn lies, and statistics. Statistics, there's nothing wrong with a statistic. It's what you do with it. It's what you do with it, right? It's like having a gun. The gun isn't going to kill anybody. The person using the gun is going to kill somebody, that maybe, perhaps. It's once you, these are just numbers. These are static numbers. If you put them into a newspaper and knowingly only show the most extreme cases to sell a newspaper or to raise an issue, then you're the one that's the damn statistic in that respect. Does that make sense, Gary? Thank you for touching on a very important point. All right, let's get away from uninsured. Let's get away from uninsured. Let's talk about Mount Bachelor, and my son at Mount Bachelor in particular. That's him skiing down something, I forget when. This, ticket prices, Mount Bachelor. Ticket prices, Mount Bachelor. What I want you guys to do